chief guest.
Kindly hold on. Raja sir is having some network issue. We'll join in a minute.
Ma'am, good afternoon, madam. It is audible, ma'am?
Yes,
Yes,
scientist.
sir. It is
Yes, sir.
audible.
Okay. Thank you, sir.
Special welcome, and don't waste the time. Please start.
Okay, sir. Thank you.
Sir, Raja sir will be coming. Sir, just a minute.
No problem, madam. I will wait.
Sir, good afternoon to one and all present in the FTP. I welcome Dr. P. Tirunakarasu and I would like to introduce him. Dr. P. Tirunakarasu has diverse work experience in academia, research, and industry. He is currently working as an associate professor at Dr. MJR Education and Research Institute in Chennai, India, where he previously served as an assistant professor and a postdoctoral fellow. Before that, he worked as an assistant technical manager at the Rajiv Gandhi Center for Aquaculture in Chennai. Dr. Thirunagarsu holds a PhD in marine biotechnology and a cancer pharmacology from Annamalai University, where he also earned his MPhil in marine biotechnology and MSc in biotechnology. He has also completed courses on proteomics, cell culture, and educational models. Dr. Dr. Thirunakar's research work includes his dissertation on the effect of sugarcane bagasse on penicillin production in solid-state fermentation, and his MPhil thesis on the effect of ursolic acid from a hollow pipe Salvadora persica against HT1080. 1080 fibrosarcoma cell line. His PhD research focused on anti-gastric cancer studies and Rhizophora macronta, a derived squal using in silico, in vitro, and in vivo approaches. While his postdoctoral work involved the isolation, identification, characterization, and formulation of an anti-gastric cancer compound and herbal tablets from the mangrove plant species Cereops decantra. Dr. Tirunagorse has presented his research work at several conferences, including the Indian Plant Science Congress, sorry, including the Indian Plant Science Congress Forum, the Asian Cancer Registry Forum, and the International Conference on Current Trends and Emerging Challenges in Biological Sciences. He has also worked on a patent that was published in 2021. In addition to research, Dr. Trunagarse has also focused on teaching and project management. As an associate professor, he is involved in teaching undergraduate and postgraduate students and guiding the research projects. His project management experience is evident from his work as an assistant technical manager at the Rajiv Gandhi Center for Aquaculture. Overall, Dr. Tirunakarsu's work experience and educational background make him a valuable resource in the fields of biotechnology, marine biology, and cancer pharmacology. His research work, teaching, and project management experience highlight his declaration to these fields and his commitment to make a positive impact through his work. And also, as his name implies, Dr. Tirunakarasu, he is the king of tongue in his biomedical field, research of field. Thank you, sir. Once again, I welcome you for this FTP.
Thank you very much, sir. Raja, sir. You are given very nice and wonderful introductions about me. And once again, I thank to management, Dr. MGR Education Research Institute, and I thank for HOD sir, Dr. Saravanan, and I thank to Parisa madam, given me the wonderful opportunities to share my research knowledge. Okay. Today, I'm going to given the talk about in the 3D cell culture for cancer drug discovery through the nanotechnologies approaches. Because this FTP program for most of the peoples from the EEE department and biomedical engineering, I thought you are not experienced in the 3D cell culture and others. Nowadays, this 3D cell culture is very important field. You can get the fund is very easily, and also in the Indian, we only culturing in the 3D culture through the patient derived organoid culture. Because why we go for in the organoid culture? Nowadays, the disease is more accumulated. The disease was caused many disease. Even there is no any diagnosis kit also. Because I tell only two example. There is anybody that for the liver cancer or liver failure and kidney failure. It is there are many people is affected nowadays, because this problem is major issue in our country. There is no any donor to given for the kidney transplantation and liver transplantation. Even in the liver, recently the Manobala is also is gone due to the liver problem. Especially for there are the liver problem. Those who are drinking, the liver is affected. That is for non-alcoholic fatty liver. Those are not drinking, that people also affected for the liver fatty liver. That is a non-alcoholic fatty liver. So because I'm not drinking, but the non-alcoholic fatty liver will accumulate. What is the reason? Because lack of exercise, we are not taking the enough food, we are not taking for in the green and vegetables and fruits. That problem is the fatty liver is formed. It is a silent killer in the fatty liver. It not cause the any problem, or it not given the any symptom up to in the third stage. So once the third stage is go, that problem for it's going to very severe, and treatment is also very difficult. And the stage 1 and stage 2, it is reversible. So in this liver or kidney is a major problem for the people affected. There is no chance to the curing the disease in the kidney and liver. But as a scientist, as a biotechnologist, as a biomedical engineer, we have produced in our lab for in the kidney transplantation purpose. We can culture in our lab, and the liver we can culture, and the kidney we can culture, and transplant in the particular patient. Even though, for example, one man is affected in the liver problem, that man father given for liver, but it is not the histocompatibility. It is called the histocompatibilities. That histocompatibility means that is in the biological word. It is not form, or it is not suitable for in the particular patient. Because that purpose we are taking the 90% of the liver, for example, 90% the liver is affected. In the 10% the liver is a normal tissue. We can take the tissue from the 10% of tissue. we can culture in the artificial environmental in the animal tissue culture laboratory, and we can able to develop in the 3D organoid, then 3D organoid with going for 3D bioprinting. So that purpose we can drying or we are doing in the 3D cell culture works. So now you are understanding about the 3D culture, why we are going for 3D culture. So 3D culture is a one of the important work or important research work in the nowadays. Those who are affected for the kidney and liver, those who are wanted to for the, organ donations or organ transplantation. That purpose we need for in the 3D culture. So in the 3D culture, we are doing for now we are concentrating only for the cancer patient. First, we can understand about the cancer, because if it the biotechnologies FTP, I'm not explain more about in the cancer. This is in the biomedical and in the EEE department, means I can explain the cancer. What is cancer? Because our cell is normally it have the 43 chromosome. It is very, you all very well know about the 46 chromosome. In the 46 chromosome, there is pair for 23. In the 23 chromosome, we can got for our mother, and another 23 from the parent, from the father. So in the 46 chromosome, every time it is going to divide. So if every time is dividing, the cell has is very much, it is cell how the very well, there is no any problem. For example, I am working, there are the 5 people are working in the on industries. If the industries, the working, the 5 people that eating the same food and they staying the same place, but the 2 people is affected for in the cancer and the 3 people is not affected in the cancer. What is the reason? Because we have the more antioxidants, we have the enough immunity powers, there is no attack in the cancer. But in the radiations, there is affected in the 2 peoples, and the 2 peoples, how they affected, because for example, this is my pen. This pen have the our DNA sequence. The DNA is where is that? You know that is a DNA. The cell, inside the cell, inside the chromosome is there. In the chromosome, our DNA molecule is there. So like you can imagination of this pen is our DNA. In the DNA, every time there is going for in the damage is happening. The damage is not only for those who are affected in the people in the cancer, the all people going to damage in the every time. Now I'm speaking, that time also that damage is happening. You are listening, that time also damage is happening. But our body itself, there are some repair mechanism. If the repair mechanisms are very high or repair mechanism is very powerful, we need for in the antioxidant capacity. So there is in the DNA is going to affect anything for virus or any chemical food or any radiation. So the DNA how to damage. In the DNA is damaged, it is going to repair some our body itself, that it is going to repair. It is unable to repair, that it's convert the cancer. Those cancer is a abnormal cell growth. It is a normal cell. It is a convert the abnormal cell growth. Simply I telling, you know that is Indian movies. You know that that is Indian movies for in the city is one people is that is cities is a normally first time it have a very good man. He is working many things. His read book is very well. He is listening everything. But only the chip is changed, it is converted in the another way. So that is a normal cell is working very properly, is very controlling. But when the mutation is occur or damage is occur, that mutation is not cured, it continue the process, it convert the cancer. So okay, so your cell is the in the round is that is a cell cycle. You can see this. This is a G1, but that is a cap phase. Our cell every time is doing this process because that is a 43 chromosome. 46 chromosome. It is going to in the cell division. That is G1 phase. In the G1 phase, there are the cellular content and excluding the chromosome are duplicated. So whatever the enzyme, whatever the proteins, whatever the other factors need in the S phase, the G1 phase is prepared. and it is converting the 46 chromosome in the S phase. That S phase there is dividing in the 46 chromosome, again 46 chromosome, because you can check here is a checkpoint. That one line is there. There is a permit to allow the in the the same thing here in the G1 phase, in G2 phase, it have the 46 chromosome. It is easily move the S phase. It have the 45 chromosome. It won't allow. Go and check and return back. If you have the 47 chromosome, they won't allow, because you go and check and return back. So like this, the chromosome is increase or decrease, they won't allow. They have allow for only in the 46 chromosome. It is going to go into enter the S space. There how the system is very well and working very well. But for example, we don't have any immunities power. We don't have the antioxidants, so that it is it have the 47 chromosomes. It unable to rectify the problem. That means the DNA repair mechanism is not working properly. Is not working properly. There is a 46 chromosome. That 46 chromosome, it alone how to synthesis another one cycle, because the 46 chromosome is going and routinely the synthesis of a cell. But the 47 chromosome, it is abnormal cell. That is abnormal cell. It is called the abnormal cell division. The abnormal cell division, it is produce the abnormal protein. So abnormal protein, it's produce the abnormal cell. That abnormal cell is called as a cancer. So that is abnormal cell is produced, that is cancer. So that is cancer, the major problem in the world nowadays, because the cancer nowadays there are so many people are doing the research in the biology field. There are 95% of the people in the world that are doing in the cancer research only. I think you are you know that now about idea in the cancer also. Now I go to next slide. Because why we are cancer research we are doing, and during the last 13 years in the cancer research, I have discovered many drugs. I have published more than 90 papers, and I applied for the 5 patents, and there is no use, because every time every day the research is doing, but the cancer is paused, and there is no any medicine still now. So yes, there is in the India there is many cancer. The 90% is the metastatic cancer and 10% is the primary cancer. What is metastasis? The metastasis is because the one person is there, the person is affected the breast cancer. The breast cancer, world #1 cancer. The breast cancer is a world #1 cancer. This breast cancer is it is in the breast, but in the metastatic states, it is going to spread in the bone also. It is going to spread in the other organ, stomach also. That is the metastasis. The cancer is able to spread to the other organ. That is a metastasis. If they are able to spread to other organ, it is unable to cure in the cancer. So this in India, there is in the cancer last 2020, there is the 4,38,297 male is a death, and the 4,013 381 people is dead, and the cancer patient in India 2.7 million on new registration of the cancer per year, 13.9 lakhs. It is very shocking news, and mortality rate for 8.5 lakhs per year. That's why we are doing the cancer research. There is no any medicine. Once the cancer is confirmed, your death also is confirmed. So see this cancer status in India, because in India only, not in the world, that breast cancer is a 13.5%, and the lip and oral cavity, that is a oral cancer, like cigarette and nicotines. So like there will cause the oral cancer. It is very dangerous cancer, 10.3%, and cervical cancer, because the cancer is mostly affected in the girl, in the ladies, because the breast cancer is one of the important cancer. Another one is a cervical cancer. If the cervical cancer is caused by human papilloma virus. That is why the reason is a cervical cancer is caused. That is the ladies don't those who not follow in the hygienic. That is caused. That is human papilloma virus. That there are multiple contact. So these are all the reason. There is another reason also is the for in the cervical cancer. Lung cancer, the men is mostly affected for the lung cancer, and the colorectal cancer. It is also the colorectal cancer for 4.9%, and other cancer for 56.5%. There is a cancer is every cell is possible for the cancer. Another one shocking is in the 30 million death or rate for the predictor worldwide in the 2020. So that much important in the cancer. This is the cancer. We know the cancer how is formed. That is the cancer. What are the statistics? But now the diagnosis is very important, because if you have in the diabetes, or if you have in the hypertension, or in the cardiovascular disease, there is enough diagnosis kit is available. Because dear biomedical students, dear biomedical staff, there is no in the diagnosis kit for the cancer. Not only for cancer, there is many cancer, many disease diagnosis is lacking for in our country. Not in our country, in the world. So that's why in the biomedical engineering is need for more and more, because the recently we have the threatening from the COVID-19. The COVID-19 is formed in the worldwide is threatening, but in the RT-PCR only is able to identify. Who told is the RT-PCR is identified in the COVID-19? That's the biomedical people only. The RT-PCR who made, that is a biomedical people only that that how to make the in the biomedical instrumentation with the help of the EC and the EEE. There is RT-PCR is not that. There is no possible to identification the COVID-19. So if you are going for in the diabetic checking, there is a glucometer is that within fraction of second that we can take the blood and we can determine though you have the diabetes or not. Or hypertension, we go for in the hospital. They got within the second they can identify our blood pressure. Or other cardiovascular disease, the EGC and echo is everything is possible. They are identified within 1 hour or 2 hours. Not 2 hours they are identified. But there is no specific test still now in that to determine the cancer. How they determine the cancer? How they confirm that cancer? Based upon the blood test, based upon the scanning, based upon the your history, based upon the your patient condition, they have confirmed you may the cancer. They are not confirmed clearly you are the cancer, but you may be cancer. So we are the biomedical, we have the EEE or EC, we can identify in the instrument to diagnose in the cancer. So the diagnosis of cancer, how the diagnosis in the nowadays. So how the diagnosis, for example, any person is affected in the stomach cancer. In the stomach cancer, how is formed? We can take the spicy food or the ulcer. The ulcer will we won't take any medicine or we won't take care in the ulcer. That ulcer is inflammation. Then it is caused as the gastric cancer or stomach cancer. So through that the stomach cancer, we can how to identify. They won't take the blood test. They will take for in the endoscopy. The endoscopy means the tube are inserted inside the intestine and they take the biopsies. The biopsies is going for histopathological studies. Histopathology studies. This result will come after 10 days. Then only they will confirm you have the cancer. So that is for invasive method, free surgery. That is an invasive method. Long time it will take. That's why I'm telling you it will take for 10 times. And surgery and unable to assess a tumor evolution. In this process, the tumor, how this formed, எப்படி வந்து tumor வந்து evaluation ஆகுது, எப்படி வந்து மாறிட்டே போகுது. Because tumor is very fast. Are unable to identify nowadays in the free surgery, or there is no any facility, no continuous monitoring. Any person is affected the cancer, but they are given the drug, but they are unable to monitoring whether his cancer is curing or not. They are unable to monitoring through the methods. So that, and also they are going for so many PET scan, MRI scan, and fused PET or MRI scan. There are so many methods there. We are the scientists, we are the biomedical engineering, we are the biomedical students, we are the biomedical staff. We can identify, we can discover in the only one diagnostic kit for the cancer. So that is our aim, that is our lab aim. So there is some simple example is that the simple procedure is that we are doing in our lab, because the liquid biopsies. What is liquid biopsies? You know the liquid, our body is a buffer. Our body is maintaining the pH. So the pH in the blood is a 7.4. So it is how the whatever the disease is caused, we can take for in the blood. Even though the cancer also is possible to the cancer is spread to the in the blood, but we are not checking the blood, we are taking the tissue only. But there is some the cancer after forming, it will spread to the blood. There is blood, there how the ctDNA, that is tumor circulating DNA is there. It is very easy, we can take. And nowadays they are doing many research through the ctDNA, that is a tumor circulating DNA, or tumor circulating tumor cells. We can identify very easily the cancer, very early stage of the cancer. And it is a very less cost and minimal invasive. No need for very hard work to taking the biopsies and insert the endoscope in the inside. No need. It just we can take the blood and isolate the circulating tumor DNA. On short time only it is needed, and continuously is very easy, because I'm telling, if you're given for any drug, we can identify continuously whether the drug is working or not. So that is very easy, because daily we can take the blood and we can monitoring whether it's our drug is working or not. But and then it is a very pain free. So this the circulating tumor DNA, we can doing so many work. Our lab also doing for so many work in the circulating tumor DNA and early detection of the cancer. This is liquid biopsies. In the liquid biopsies, because the needle in the heart stays, because it is a very big one in our bodies. In the big one body, we can inject only the needle. We can take our tumor circulating cell or circulating tumor DNA. In the circulating tumor DNA, we can isolate, or we can identify in the screening the cancer whether it's a tumor is there or not, and diagnose the cancer, which stage, because the 4 stages in the cancer we can identify, and we can staging prognosis, stage and how to prognosis in the next day. And also we can therapeutic purpose also we can using for circulating tumor DNA, and you can monitoring whether you can give for drug, how we can monitoring in the drug. So this is the using for plasma. This is once we can take the blood and it is going isolate the plasma or serum, we can identify the CT's circulating tumor DNA. Next, that is a cancer diagnosis. I am talking about the cancer diagnosis. I'm telling now one words, the prevention is better than cure, because once the cancer is formed, whatever the disease, not only the cancer, the disease is caused, the curing is very difficult, especially in the non-communicable disease, like in the diabetes, hypertension, and cancer. So in the non-communicable disease, it is a curing is very difficult, and especially in the cancer, it is not possible to the curing. Okay, that is a fashion field for we can using for nanomaterials. So the nanomaterials very important. It is a very emerging field for nowadays, because the nanomaterials, it is a very small size, 1 nanometer to 100 nanometer. It is easily traveled to the whatever and target site, and going to deliver and cure that in the particular disease. So that is a nano medicines. And is a microfluidic device. Nowadays they are doing the microfluidic. What is a microfluidic device? The device, it is made from the mechanically. That device, it is mixed with the two solution. For example, I want to mix some solution, the A and B solution I take, and it is going to mixing properly and rotate. I going for magnetic steroid. So it is rotating, then it have to whether the solution is properly say synthesis or not, or properly mixing or not. So it will take the time, but no need for time. Within the 5 minutes, 10 minutes, the microfluidic device, we can mixing the solutions. And this through this nanomaterials with in the circulating tumor DNA, we can biodiagnosis the cancer or any other disease. We can easily identify in the disease. And the tissue engineering, you know that the cells is going to and the tissue, the tissue, is a group of tissues is converted in the organ, then it is going to for organism. So these are the tissue engineering we can develop. That is a 2D and 3D culture nowadays they are also doing. Then advanced drug delivery system also we can doing through this nanomaterials, advanced drug delivery system. For example, the brain tumor. The brain tumor, it is curing is very difficult, or given the drug is very difficult. But the nano medicines or nano drug, it easily travel the blood-brain barriers. Blood-brain barriers is barriers. It is not allow for all the components. If any pathological condition, it allow for all the components. For example, I have the headache. That headache, any pathological condition only, I have the headache. That means that water enter inside of my head. For example, argan or the chloroform, it is easily barriers. It easily barrier for blood-brain barriers. So now, so that is advanced drug delivery system we are using, and bioimaging, how in the organ is present, how in the drug is working, how it's a damage. These are through the nanomaterials field we can identify in this method. Next, we are doing in the animal tissue culture lab for the 3D and 2D organoid culture or in the spheroid culture. These are all the facilities need for in the to develop the 3D and 2D culture. So this is a CO2 incubator. It is very important. This CO2 incubator to maintain the carbonic buffer in our cells. This is a centrifuge. It is available in our lab. It is provided our president sir. The recently we can purchase this CO2 incubator is around cost for 5 lakhs. This time I thanks to our president sir also. They are given the management fund and purchase this CO2 incubator. And this is for in the centrifuge. In the centrifuge need for I telling for we take the blood sample and going for collect that in the circulating DNA through the centrifuge only possible. This is a ELISA reader. Whether the live cell or dead cell is there, after given the drug, you can we can identify in the ELISA reader only. That is water path, because the cell is very cool condition, because with the we can storing the refrigerators, that we can use for water path. And this is a fluorescent microscope. Through the fluorescent microscope, we can identify cell staining, and we can identify cell stages and cell size. Everything is identified. This is a laminar airflows. It is a working table. So through the working table only we can using in the 3D and 2D culture. It is very sterile condition in the lab. Next, what is 3D culture, sir? You are telling what is 3D? We don't know, sir. 3D, sir. So what is 3D culture and 2D? Before going to in the 3D culture, we know that in the what is the principle is culture. In the any cells we are culturing, we need for in the three wordings. Very biological word is very important. What is first words is a totipotentiates. What is totipotentiates? Because I am going to culturing any plant, or any organ. For example, I going to culturing for the liver organ. I not take for whole liver and culture in this artificial environment or lab. I take the small piece only. I take the small piece only. That small piece is develop the whole organ. That is a totipotency. Plasticity. Now, what is a plasticity? The plasticity means, because in the liver tissue or kidney tissue or cancer tissue, we can take that cancer tissue or liver tissues, we can develop the artificial environmental. That artificial environmental, it can tolerance and able to develop. Because I am telling the one words in Tamil. Because இப்போ நான் வந்து கிளாஸ் இப்போ வந்து நான் வந்து இந்த FTP ப்ரோக்ராம்ல பேசிட்டு இருக்கிறேன். somebody is are interest, somebody is not interest. ஆனா என்ன பண்ணோம், நம்மளுக்கு சர்டிபிகேட் வேணும், ஆர் இந்த ப்ரோக்ராம் அட்டன் பண்ணணும் அப்படின்றதுக்காக இந்த இவர் பேசத்துல நம்ம கேட்கணும் அப்படின்ட்டு டாலரன்ஸ் பண்ணிட்டு இங்கேயே இருக்கிறீங்க பாரு. யூ கேன் டாலரன்ஸ் and sit and listening my words. That is a plasticity. Because we take the natural environmental, human natural environmental from the tissue, whether in the plant tissue or animal tissue or a bacterial tissue, and it give the artificial environmental. In the artificial environmental, there is so many problem, because not in the buffer is not there. There is no any blood, there is no any extracellular or intracellular, but it can able to develop the new organ. That is a plasticity. And also in the micropropagation methods, the third word is the micropropagation. The micropropagation is only the single tissue we can able to mass of culture. That is a micropropagation. So in the 3D, so in the three concept, very important, whatever the plant tissue culture and the animal tissue culture. What is 3D culture? Nowadays, whatever that is a 3D. There is a LED and 3D culture. So 3D print, the cinema is the 3D printing. So here is an artificial create environmental is which biological cells are permitted to the grow interact with the surrounding in the all the 3-dimensional structure. We need for 3-dimensional structure. That is a 3D culture. It is a advanced method for in the 2D culture. Actually, it's a mimic the natural environmental. For example, on cancer patient or any patient, diabetes patient is there. I'm going to discover any drug. I given for some plant drug to the particular patient. Whether it is curing or not, sometimes it is going for adverse effect. So that it is not ethics. The patient is not taking your drug, and also it is not ethics to test any drug to direct the human being. That purpose will go for in the 2D culture. In the 2D culture, there are some disadvantages is that purpose will go for 3D culture. In the 3D culture, we can view for full view in the cells. We can analyze for fully what the happening. For example, we are given the drug is it is curing for in the disease. For example, hypertension or diabetes, it is curing the disease, but it is induced the other disease. The diabetes is curing, it is increased, it is induced the hypertension. It is curing the diabetes, or it is induced the cancer. It is curing the arthritis, it is induced for in the thyroid problem. So that is that purpose we don't go for directly in the human. So here is taking for the human, we can biopsy sample cells from the biopsy or the resections, and is a monolayer culture. What is a monolayer? And in the culture is the two types of the culture is there. But one is the monolayer and suspension culture. Because in the monolayer, the culture, because we are developing the artificial environment of the culture, the cell are developing, it is attached or glass or plastic. With the help of the plastic and glass only, it is able to develop. That is a monolayer culture. The suspension culture, the culture is going to floating and growing. That is a monolayer. Then it is the culture in the 3D layer. Then generation of the craft, that is the organ we develop. Then we can crafting change in the human being. This is an example or in the differentiation of the 3D culture. The 2D culture is very simple. We need this flask is name of the T20 T25 flask we can develop in the cells. We can able to develop in the culture, and the 3D culture, this is a 3-dimensional cells we can using we can develop the cells. And the 3D physiological system, what is that telling for microfluidic culture? The microfluidic culture, so everything is possible. Now we have identified in the Covaxin and the Covishield, we are all are taking the vaccine. When drug is identified, it will take for long time, because it will take at least 15 to 20 years. ஒரு ட்ரக் வந்து கண்டுபிடிச்சு அது மார்க்கெட்டுக்கு போகணும் அப்படின்னா it will take for 15 to 20 years. But how is possible, sir, today within 1 year we have affected the coronavirus, and we have produced for in the Covaxin Covishield. We are all taking the Covaxin and Covishield vaccine 2 times. The how through the microfluidic method only possible. The scientists how they discovered the microfluidic device. In the microfluidic device, what in the inside the human organ is present, in that same is changed in the chip. The same is transferred in the chip. Like see this, this is a vascular channels also present. This is what is present in the microfluidic device. That is extracellular matrix also present, organ specific epithelial cell also present, the channel separating porous membrane also present. There is organ specific epithelial cell and parenchyma channels. Everything is present in the microfluidics. It is man-made products. It is a mechanical made is a device, that is a microfluidic device. So you can apply the funded project, you can doing the research in the 3D culture and microfluidic culture. There is no any person in India, only the IITs are doing the microfluidic culture, and 3D organoid culture there is no one person in the doing in the organoid culture. What is the difference between in the 3D culture and 2D culture? Because simply we can take in the any tissue and we can develop in the lab, that is a 2D culture. And 3D culture that we can need for some special media, we can do for some special keyword and special instrument we need, then only possible to the develop the 3D culture. So just we can go for in grow the flat dish dishes or the attachment. It need for the 2D culture only the Petri plate is enough, but in the it is cells is attached to one to another, and the cell to cell attachment and synthesis, it is the cell to cell attachment in the 3D culture. Cellular communication signal is minimal. The communication, the signal transmission is very, very important. So the signal communication is very minimal for the 2D culture. In the 3D culture, cellular communication signal is maximum. It easily communicated, because in the 3D waves we culture in the lab. That is grown on cells simply with the diverse function and the native tissue. The grown the complex phenotypic and the function that closely mimics the native tissue. So it is mimic the in the human beings or any animal in the natural condition. That is the 3D culture. In the not valid for targeting and testing the new drug discovery. So more valid in the targeting for testing the new drugs. It is a multi-layer cell formed, only the mono-layer cell formed for the 2D culture. So these are all the differentiation of the 2D and 3D culture. Very less person are doing the 3D culture. In our lab, we are first time we are doing in India for the 3D organoid culture in our lab. That is in the culturing I was telling for 2D, 3D. Sorry, we are not understanding. So very simple. That is atom is there. That atom is formed molecules. That molecules is converted the macromolecules like a protein, carbohydrate, and DNA. Then it is a organelle will form. These molecules all will form. All is a organelle. That organelle, it is a cell is there. One part is cell is there. That cell is group of cell is formed a tissue. That tissues group of tissues formed the organ, and the group of organ the organ system. The group of organ system developed the organism, whether it is a human organism or animal organism. These are all the we are doing the tissue engineering this part only, or we are doing the cell culture from this part only. Oh, this is in the organization level or tissue engineering, tissue culture. So in the culturing for epicenter of the drug discovery, especially in the 3D culture is very, very important or novel work. We can identify everything through the 3D culture. We can identify anti-cancer drug. We can identify in the CNS injuries, drug discovery from the CNS injury, and also for toxicity assessment. And the previous slide I explained about in the toxicities, because you discover any drug, the drug is curing for in the particular disease, but it has some adverse effect. So how to identify? So through this 3D culture, we can identify that adverse effect. And the thyroid treatment nowadays in the thyroid is very common problem for the especially in the female. So that thyroid is developed through the 3D culture, and the generation of the function of the organ. Like nowadays in the organ donations is very, very problem. Even in the father or mother, even for son, transfer the son to the organ, that is also histocompatibilities. It is caused some problem. And if you are taking the same patient organ, and we can develop in the lab and go for bioprinting, 3D bioprinting, we can it is very suitable and is very attachment, and it is very working. So that is function we identified through the 3D cell culture. And tissue engineering, there are so many I discussed, that is the 3D and 2D cell culture, that tissue engineering we can using. And study of the biomarker. So biomarker means whatever the disease or cause, it is some problem in the disease, there is in a biomarker. Biomarker means there are gene. The gene only the possible for the to cause the disease or curing the disease. That gene we can identify through the 3D culture. See, this is a diagram is very, very very important, and it is easily understand in the 2D and 3D cell culture. That is a natural. We can take any bone marrow or extracellular membrane or tissue, we can develop, that is under microscopics, we can easily identify that is a natural of the cell culture. And 2D culture we can using for this in the T25 flask, and earlier slide I explained about in the 2D culture, 2D cell culture. Through the 2D culture, we can see that bone cells and liver tissue and thymus tissues in there. And 3D is, this is a 3D. The third one is a 3D. We can develop the 3D matrix with the help of the scaffold. We can develop that in the 2D and 3D culture. What is the techniques we can follow in the 3D culture? That scaffold based 3D culture and non-scaffold based 3D culture, and bioreactor based 3D culture, and gel based 3D culture. There are a different type of this. The scaffold is nothing but some of the supporting materials the cells have to develop. For example, I want to culture on the virus. I want to culture the virus, because especially for the coronavirus. I want to characterization of in the virus. The virus cannot develop without any animal tissues. You well know, or you have the well awareness about the virus, because the COVID-19 non-biologist also there is learn many things about the virus. The virus is a non-living in the outside. Once it is entered to the bodies, it is convert the living. So I want to culturing in the virus, it need for some animal tissue. So without the animal tissue, the virus is cannot develop, but not like that in the bacteria and fungus. Only the media is enough. The media is enough to develop the bacteria and fungus. So then the same in the need for some supporting material, that is a polymeric material, other nano material need to develop the 3D culture. That is a scaffold. The scaffold is nothing but there's some supporting material. So the virus can develop with the help of the animal tissue. It is going to attach and develop in the animal tissue only. Generally the virus culturing purpose they are using for egg. And non-scaffold, there is a hanging trap without non-scaffold. Without scaffold also they are developing the cells. And bioreactor, because I am developing for some stem cell, I develop the multi-quantity. It need for some bioreactor. The bioreactor is nothing but that is a fermenter. The fermenter is need for some of the aerator and agitators, some pH maintenance. So that is develop the mass quantity. That is a bioreactor. This is a bioreactor, 3D bioreactor. And gel. For example, I can develop the any tissue like bone is fractured. Bone means the bone tissue or fractured. It is a very soft tissues. It cannot develop very easily. In the soft tissue development, we need for gel. So that is gel is developed very easily. That is in the 3D cell culture. And what is the scaffold? Is I'm going to very fastly because only 4 o'clock I'm going to finish. This is the scaffolding means that is a supporting material. I already explained. That is a glycolide copolymers. Lactide copolymer. So that is through this supporting material we can develop the regenerative medicine. What is a regenerative medicine? Any defective disease is that we can develop the artificially the tissues and transfer and remove the defective tissues. We can add the newly developed tissues. That is a regenerative mainly. That is mainly used for in the bone and cartilage and skin and vascular, neural and skeletal muscle tissue using for scaffold phased method only. And it is in vitro testing cells are grown the modern tumor in the lab. Next, the biological scaffold. In the biological, the recently we are published. There are 3 papers in the 3D organoid culture, 3D organoid cells. That is, it is biological scaffold means the scaffold that is for some polymers we are using. Now in the biological scaffold means that is a protein such as fibronectins and collagens, laminins and gelatins. These are all the scaffold to develop in the culture. And previous suitable environmental for the anatomical, physiological and development of the cells. So through this method we can biological scaffold also using. The micro patterned surface microplate. This is the another one methods. We can develop in the culture, a 3D culture. In the 3D culture, we need for some cuvette. We need for some square or round or a slate pattern. So based upon this size, that is a scaffold. I already told that is a monolayer culture. It is a monolayer culture. It is attached to the bottom of the cells, and it can be able to develop. So like this, it is used as the scaffold. It is not using for protein as a scaffold. It is not using for any polymer of the scaffold. It is using on the plastic or glass scaffold and be able to develop the culture. Next is a non-scaffold also is possible, like hanging drop microplate methods. The non-scaffold means no need for anything scaffold. We can add taking the pipette ourselves and injected in the any wells like a 96 well plate or other plate or 6 well plate or 12 well plate. So that plate it is able to develop. That is developed in the, it is called as it is spheroid. It is not a organoid. There is a difference is that what is organoid and spheroid. This is a spheroid. It is shape itself based upon the trapping. It is the shape is developed. That is a spheroid size cells. And spheroid microplate. There is using for some the spheroid in the microplate. That is a 96 well plate, 384 well plate. And there is so many cuvette is available for non-scaffold method for spheroid microplate. And non-scaffold based and microfluidics. This only is very, very important in the microfluidic nowadays. Only the minimum person are doing for the microfluidic methods. The microfluidic method, we can easily develop our cells, or easily culture our cells. Because it is doing in the IIT also there is Ashish Kumar son, that scientist Ashish Kumar, they are doing the microfluidic culture. The microfluidic culture, it is very easy. They use it to treat the 3D architecture of the in vivo tissue and tumor. The what in vivo is present through the microfluidic device only they had identified in the coronavirus, that is a Covishield and Covaxin. Whether it's after 20 years how the human body is working in the our Covishield and Covaxin, they have identified from through the microfluidic culture only. It creates a heterogeneous model that permit the continuously supply for necessary nutrients and growth requirement, as well as the removal of the waste also. It is contained, there's a glass or silicon or polymer such as the polycarbonate and polystenes and the chromatography paper and filter paper also using. So this method in the bioreactor, already I explained that the bioreactor, it is we need for mass culture, we go for in the bioreactor. In this bioreactor we can develop that because anybody is affected with arthritis. Dr. Ravi is Maruti Hospital Trichy. There is 3D stem cell develop scientist. They have developed some cells, only one injections, that is 1.5 lakhs per one injection. If you have arthritis, we can inject it, take your own blood or your own stem cell, and it is able to develop the culture in the laboratory, and it have the injected in the bone or joint, and 10 years no pain, no anything. That is it how the develop in the whatever the defective in your tissue. So that purpose will go for in the bioreactor. The mass culture purpose only they go for bioreactor. And gel, already explained this gel. The gel means it is some stiffness that is mimics the extracellular matrix. Some the extracellular matrix are soft tissue or some collagen based tissue. So the tissue developed purpose will go for in the gel gel type. So now I talk about in the 3D culture and 2D culture and cancer. Now this through 2D culture and 3D culture we can solve through the nanotechnology only, through microfluidic nanotechnology. So now we are going to I explain about the nanoparticle. What is nanoparticle? So nanoparticles, it is a very small particles, and these nanoparticles for 1 nanometer to 100 nanometers, it have the various shape and various size, and the nanoparticles we can able to develop in the whatever the materials. Why they are choosing the nano material? Because it is very small part. In the our drug is not traveling the any part. Through the nano carrier or nanoparticle, our drug is easily will travel and going to in the particular target site and curing the particular disease. That is a nano material. So that's why the nanoparticle is we can develop. See the first this one is for bulk material, and it is form powder form. Then it is produced for nano material. On the bottom to synthesis, it is atoms, and it is splitted in the cluster, and then it is form the nano materials. Then there are the many type of the nanoparticles, organic nanoparticles. So this is a organic, and inside the nanoparticle is that organic nanoparticle easily will travel in the particular site. So the nanomaterial we can code it in this, because we know this that kids is not like any medicine. It take the medicine directly for a tablet, it going to vomit. We can insert that tablet inside the banana, and then we give the banana and easily take the kids. So like this, our nanomaterials is a small particle, but it is not travel in the particular site because very small. But it is going to travel only the banana. It's going to inside. So the inserter like this in the organic nanoparticle, we can insert our nanoparticle and easily go in the direct place and open, and disease are securing, or and the problem is solved. And polymeric nanospore. The polymeric nanospore, that is a polymeric, that is a PLG and other materials that is polymeric. That inside we can inject it, like in the coated medicine is there. There are so many sugar coated medicine, like that sugar coated medicine means that is some palatable compound, and inside we can add the some coated sugar, and the kids are taking very easily. Like this, that is a polymeric nanospore as insert inside and easily is travel. That polymeric nano capsule and polymeric micelles and liposome mediated nanoparticle. Liposome, our body is made of the lipid bilayer. If any drug throw the lipids, the plasma membrane, our body is a plasma membrane, it is easily absorbed. But inside our nanomaterial is there, it is going to inside and it is going to activate it. So that's why there is a tendrimer. There are so many nanoparticles, and it is size also various size, like a star size, cube and shape, sphere and a plate and rod. There are so many, and also there are so many nanoparticles. There is a cold nanoparticle, iron oxide nanoparticle, carbon nanotube, microspore, silica nanospore. There are various nanoparticles. Our lab we are doing almost all the nanoparticles and for that discovery. And it is a nanoparticles properties. The first one is a surface functionalities. is very, very important. When the drug is the nanoparticles is developed, there is in the extracellular membrane, there is so many receptors binding. That receptor, it is going to ligand and going to bind on particular region, and it is curing a particular disease. For example, the antigen antibody reaction are lock and key methods. So that is in the surface. In the surface functionalities, we can using in the nanoparticle methods. Because now I feel maybe I feel like in the fever in the classroom. I'm not taking any medicine, because after the class I go to home, then the fever is gone. What is the reason? Because of my immunity power is working. So the immunity is how is working, because the receptor is the any foreign particle enter to the bodies, that is known as the antigen. It produces the antibody. That antibody is produce the it is able to kill in the particular antigens. So there in the happenings antigen antibody reaction. That antigen antibody reaction purpose there is the nanoparticle. There is so many multiple receptor is possible, and there is various size and particle shape also. There are varied plasmogen particles, and surface area, it is very surface area is very high. So that in the nanoparticles, and particle size it's also various size, and composition there is a different color I given, that is a composition also very much, and the surface crystalline crystalline structure, the nanocrystalline structure, it is very much useful for in the nanoparticle properties. How synthesis in the nanoparticle? Because nowadays there are so many nanoparticle, there are so many person are doing the nanoparticle, but there is a three method in the chemical synthesis, physical methods, and biological synthesis. The chemical means the two chemical I take, and the two chemical is added, and after adding I going to some rotate and magnetic steroid the synthesis of the particle. And the physical method, because any metal I taking, in the metal especially in the proton, and with the solvent, any solvent, the suitable solvent, then the nanoparticle synthesis. And biological method, I take for one plant, and I going to synthesis for similar nanoparticle or cold nanoparticle, and both are mixing in the conical flask and magnetic steroid, then how to metal ion and biological substance tell the synthesis. So these are all the three types, and it is various type, like I explained already. There are so many type is there. That is nanoparticles. That is a nuclearization and growth and formation, and the metal precursors. One is a reduction. Next one is a formation of the first cluster. Then is a cluster, and the nanoparticle is produced. So in the nanoparticles, it is a peak we can observe in the only the particular nanometer in the particular time only. So based upon this, in the peak, we can identify whether our nanoparticle synthesis or not. This are all the instrument is needed for in the nanotechnologies laboratory, especially for UV spectroscopies and X-ray diffraction and FTIR and SEM, TEM. These are all the data. I will explain one by one in the next upcoming slide. Sir, how is working the target in the nanotruck? Nanotruck is how you see. See, this is in the cold nanoparticle. That is a cold nanoparticle we can synthesis through the biological method or chemical method or physical method, whatever method we can synthesis. In this, we can in the metal, and we can code our particular plant compound or is coded. That is how to synthesis nanoparticle. And when the characterization is over, then we can inject it in the rat. The rat have the already in the cancer. The rat have already the cancer. We can inject it in the rat itself in the nanoparticle, and it is see this second diagram. So this is in the yellow color is our nanoparticle and is spread to the body, and it have in the green color is our cancer cell. We can kill in our cancer cells only. Then it is going to cell. There is a plasma membrane, and inside the plasma membrane there are nuclear membranes there, and it is going to nuclear membrane. See the third diagram also, and fourth diagram. See that nanoparticle, it is going to break our DNA or condensation of the DNA. So how it is a working method of our nanoparticles. Now the nanoparticle also over. The how nanoparticle synthesis, how is working, and 3D culture, everything. Now marine drugs. So our lab, we are doing in the marine biotechnology lab. We are doing the many marine bioactive compound also. In the marine bioactive compound are using for there are so many multiple purpose, like cosmetic and nutraceuticals and pharmaceutical, food industry, and biomaterials and functional foods. Everything is possible through the marine bioactives common, because nowadays the Pepsi is that there is adding in the ingredients the some red seaweeds, apapicus. Ice cream itself they are adding for some seaweeds for flavor purpose, and other pickles they are using for pickles, and food industry. There are so many food industry using for marine product. So how synthesis in the nanoparticle? Now I am taking the we are doing the many work in the nanoparticle, and we have published the many paper also. But here it's I'm taking the only one example, the seaweed synthesis called nanoparticle for antioxidant, antimicrobial, anti-cancer activities. So how we are doing? This is here in the chlororic acid, and we can take the seaweeds, and the both are is mixing in the one conical flask. After mixing, the cold nanoparticle are synthesis there. Then the synthesis nanoparticle are going to characterization, like say FTIR, UV spectroscopy, and others. Then it have developed for in the antioxidant, identify antioxidant activities. And this antioxidant means unpaired electron. If unpaired electron is there, that is a problem in your body. But we can use through this method or the nanoparticle, this going to paired electron. So whatever our body is unpaired electron, because you are well know about in the electrical field and electron and others, because you are all on the EEE and biomedical engineering. But in the unpaired electron is very problem, but it how the converted in the paired electron. So then is antimicrobe. There are so many microbes we can take and we can use against in the microbes. Then it is finally in the anti-cancer activities. These are all the red seaweed we can collected from the Rameswaram, that is a Mandapam coast. Especially I visited with my students in the Rameswaram. This photograph is show that, and we can using for Hippinia valentia and Champia parula and Hippinia valentia. These are all the species we can collected from this Mandapam coast. And these are all the synthesis. How the synthesis we know that is a reaction between we can take for 5 molar or 1 molar. That is different upon the plant powder, and we can take the 5 molar to 1 molar. And the reaction between the algae extract and that is a chlororic acid, that is a cold nanoparticle. It showed the transformation and color from the pale yellow to dark yellow. So once before the reaction is the pale yellow, and after reaction it is converted the dark blue in the formation. Then you go for in the UV spectrophotometer. And the UV spectrophotometer 300 to 700 nanometer, we can identify in the initial confirmation and stability of the cold nanoparticle. So it is the graph itself is showing for is a 550 nanometer. We can observe in the clear peak, whether in the 2 hours periods and 4 hours periods and 24 hours periods. And FTIR, that is another one, that is FTIR, that is we can identify what functional group is present in the particular synthesis nanoparticle, like amine group, aromatic molecules, and secondary alcohol, the chemical substance observed from the Hippinia valentia synthesis cold nanoparticles. That is morphological conformations. That morphological conformation we can using for SEM and TEM. That is that SEM and TEM we can identify what is the size of this nanoparticle, because the size is very important. I already told that where the 1 nanometers, 100 nanometer is very important, the nanoparticle. It is more than 100 nanometer, it is not a nanoparticle. And shape also, what is the size? It is round shape or rectangular, speed is a shape. So that you can determine through that this SEM and TEM only. And XORD is another one method. We can techniques identify whether it's a crystalline nature our nano particles. So crystalline structure is identified through the graph is that. No time, I am going to explain this clearly. And we can identify antioxidant activities, because antioxidant is very important. Before going to test any cancer drug or any other drug, we can check in the antioxidant if it have the antioxidant activities. it definitely curing the cancer also. So that's why we go for in the three type of the antioxidant, that is the TP and hydrogen peroxide and FROF as we are using in the synthesized Hippenia valentia cold nanoparticles. In these nanoparticles, there is p values less than 0.1 only, so it is observed that it is good, and compare we can take as a control as a vitamin C. And here also, that is a hydrogen peroxide radical scavenging activities in the hydrogen peroxide radical activity also we are observing that good activities in the antioxidant, and also ferrous reducing power also we are observing is very good, is p value is less than 1 only. Through this Hippenia valentia cold synthesis nanoparticle, they have the increase the ROS level and the antioxidants, they have increased the cytotoxic activities, and they have the increase the DNA damage, and they have increased the mitochondrial membrane potential and the apoptotic metabolic changes and lipid peroxidations. We are doing in the cancer activities, especially for 2D and 3D culture. How doing the 2D culture and 3D culture? Because we can take the cells from the NCCS, National Center for Cell Science in Pune. After that, we can take the media and discard that media, then go for in the BPS, so that is a profit buffer saline. And after the wash, we can take the we can add for the some media, and we can develop the cells. That is after that, it develop the cells. In the cells, once it's attached or the clear, once it is reached for 100% confidence, then we go for the treatment. So the treatment purpose, the A is that is controlled, and it is a P is treated, and C also treated, and D also treated. So we can take for a different concentration. For example, 1, 2, and 50 mg per ml we can take, and 50 mg we can identify the IC50 value. IC50 value means that is a incubation concentration. In this studies, we can confirm or identify the 23.68 mg per ml of our IC50. IC50 value, what is the IC50 value? Because what is the off concentration curing the particular disease? We all well know that is a Dolo 650. The Dolo 650, it is a off concentration for curing the particular disease. That is the IC50 value. So same like that, we can compare or we can identify in the IC50 value in this. So then we can graph, through the graph, we can identify this IC50 value. So finally, we can further studies, we can choose one maximum dose and one low dose, one high dose. Then that is a 10, 25, and 50. This is a ROS level. Once we can take the our drug is very potential for in the against the lung cancer cell line. That is A549. So after that, we can identify whether other studies also we can confirm that whether is our drug is very potential or not. Once we can take our concentration for the 25 mg per ml, and added in the drug in the particular cells, and we can observe for 24 hours. After 24 hours, we go for in the fluorescent microscope. In the ROS we can add. So in the ROS means any cancer patient, we are going to see any cancer patient, that cancer patient has taken the medicine, that how to increase the ROS level, that is a reaction oxygen species. That oxygen ROS level is increased, that drug is working. That's we mean that is a drug is working. So that how our drug is working, we can identify because in the dichlorofluorescence. This is a dichlorofluorescent diacetate. It is a fluorescent compound. Dichlorofluorescent diacetate, and enter to the in the mitochondria. It is converted in the it is converted through our hydrolysis. It is dichlorofluorescent. Once the cells have damaged, once the cells have damaged, in the dichlorofluorescent enter to the in the cells, especially the mitochondria and DNA. That is after that it is the fluorescence. Once the damaged cells is entered, it is a dichlorofluorescent. It is a fluorescent is formed. So that's why it is a green color. It's a control. There is no any damage, but it's a treated cells. It is showing in the fluorescent, very green color fluorescent is showing. Next one is synthesis nanoparticles to observe the apoptotic metabolic changes. Our bodies every time they're doing for in the balance cell death and cell growth. It is both are balanced, there is no problem. It is both are the cells, 50% cells are growing and 50% cells are going death. Then only your body is normal. So when your cells is not developed, your cell is going to death only. That is you have the cancer. Your cell, doctor, okay, okay. That the cell is going to uh, develop and it is apoptopy. So the apoptotic metabolic changes is identified. So finally, this cancer studies we can identify, and the tracking studies also. There is no time. This is my scholar. They are doing without a scholar. I am not hearing because the scholar is strengthened for me. There are 4 research scholar, all are the regular scholar. The Sandhya is synopsis submitted. His synthesis for PLG encapsulated cold nanoparticle for drug discovery, and another one is Mujib Rahman. He is doing for development of biosensor for early detection of the cancer through the CTC, that is a circulating tumor DNA. And this girl is Gwamadi, is she has published many paper in the PhD period. He has developed the 3D breast cancer organoid cell and drug screening through a collaboration with Yale University and MMC, Madras Medical College. And this is newly joined is Hamapriti. It's doing for 3D bioprinting in the for gastric cancer. We can develop the kidney and the liver and like this. There are the gastric, that is a stomach is developed, gastric cancer is developed. And the recently our final year project developed, and we can apply it for 4 patent also, 4 patent. And this is the Kirti and Nandini. And the Kirti and Nandini is developed because nowadays the many diseases caused, especially for the disease how is caused because in the vegetables and fruits. You know that the apple itself there is some coating is there. If you're taking that coating, it is directly it causes some problem for infertility or cancer or others. So we are developing the kit. That kit is applied for 4 patent. So once we can go for in the vegetable stuff or in the fruit stuff, once we can show this kit, they are all indicated whether in the pesticide are present or not. So through this kit, we can identify whether the fruits or vegetable pesticide is there or not. And another one student, that is a Pranav and Kanagavalli, there is a develop another one pattern we can apply this year has applied. That is a creatinine is assay. Because if you are going for lab, we are checking the kidney function, the creatinine is very, very important, and it will take for 1 day to analyze the creatinine. Within fraction of second, we can identify in this kit, and this is also we can develop the sensor model. And this is another Arun Kumar and Agash and Bala, we can develop the bioprinting, biopaint. Because there is so many organic waste. The paint is very, very, very important, but the World Health Organization is indicated that the 23% of lung cancer and asthma is caused to the paint only. So through this issue, we can develop the biopainting from the organic waste. There are so many colors also we can develop it. So finally, these are all the publication for this year. We are published in the 9 paper 2023, all are impact. And I acknowledge Dr. M.G.R. Education Research Institute Chairman Sir and President Dr. Arun, Engineer Arun Kumar Sir, and Registrar Painuel Sir and VC Madam. And I thank to my HOD Madam Rajeshwari Ari. He given the full freedom for me, then only possible to achieve the everything. And I got the project also, and I completed that project for 2 years before also. Now also I applied many projects with strong support of those peoples. That is I acknowledge. Finally I acknowledge my students and my scholars. Thank you very much.
Thank you,
Thank you,
Professor.
sir. It was a wonderful session.
If you have any doubt and clarification, ask me, because it is very. I thought it is very new field, but it is not a new field. Those are the biomedical people. Definitely, you have learned this. But so many very fastly moving the slide also. The next time definitely I will give the another time for 1.5 hours. I will clearly explain very clearly also.
Okay, Professor.
Thank you very much, the HOD sir, Dr. Saravanan for biomedical and triple HOD sir, and thank you very much, the Fariza madam for event coordinators, and Raja sir, other faculty members. I don't know name in the triple department. Sorry for that, and I thank for all the faculty in the triple and biomedical engineering.
Okay, with the blessing of Lord Annamaliyar, gives
Yes,
you
sir.
a healthy and happy
Thank you,
life
thank you,
to you
thank you
and
very
your
much.
family.
Okay, thank you, sir.
Today is a special day.
Okay,
So I know only the 3D movie, 3D
okay.
printer.
Okay,
Now
sir.
only I realized that the 3D culture.
Okay, sir.
Definitely we combined,
Yes. Okay.
going to find the diagnosis of the cancer.
Okay.
So with the blessing,
Sir.
the
One more
Almighty
request. We
gives.
are developing the kit only. If anybody have in this group on the sensor facility,
Yes.
you can join with me. We can develop the sensor level, next level for the sensor. If anybody, whatever, in any colleges or professors or students, we can collaborate with me. We can develop the sensor also in future.
Okay, Professor. Thank you, Professor. Thank you for the coordinator, our Parisa ma'am, organizing such a wonderful session. So on behalf of department, for the 5-day session, see, tireless effort, the continuously monitoring of the tireless effort. Once again, thank you, the Parisa ma'am. Please go ahead.
Sir,
Thank you, ma'am.
sir, can you provide examples of drugs that have been successfully identified or tested using 3D cultures models, sir?
Beg your pardon?
No, sir. Can you provide examples of drugs that have been successfully identified or tested by using a 3D culture, sir?
Yes.
3D culture models.
Yes, now only we are doing the so many drug, the squalene we can develop in our lab, squalene. There's a one drug. Drug is from only the first time we can identify this drug only the shark, the marine shark is that only available. But first time we can isolate the drug from the plant source and through the this drug it is approval, and we can apply the pattern also.
Sir, one more question. Are
Okay.
there any ethical or safety consideration associated with the use of nanotechnology?
Yes, very good. Are you students or are you a faculty?
Students, sir.
Okay, very good questions. Because why we are going for in the 3D and 2D culture, the 2D and 3D culture, we have some problem to touching the passion. Even we can check in the animal studies like a rat and rabbit, everything. So the touching is very ethical issues there. But in the 2D and 3D, no need for an ethical proposal or ethical issue. You can do that. If you got that facility, if you got the knowledge, definitely you can do it without any ethical proposal. Any questions, please?
Sir, and what about the funding opportunities in 3D culture, sir?
Yes, there are so many. I'm telling that because the organized culture, there is no one do in India. You can go on the Google also. Anybody doing the organized culture in India. So it is showing my name only, my lab only. They're showing, but there is no why they are not touching it because the developing in the organized culture is very difficult, very challenging work. Last 3 years we are doing the developing with the collaboration of the Yale University. You know that is US biggest university, number 8 position in the world, the Yale University USA. That with collaboration with the Yale University, that scientists every week we can conduct the meeting. That scientists only guided our lab. We can develop the 3D culture.
Thank you, sir.
Thank you. Any questions?
Okay, ma'am. Okay.
Thank you, sir. On behalf of the Department of Triple E and the Academic Staff College, I would like to extend our heartfelt gratitude to you for sparing your valuable time and sharing your knowledge with us. Now, I would like to call Dr. F. Fariza ma'am to share few words.
Good evening, everyone. Myself, Dr. F. Fariza, Associate Professor of the Department of Triple E and Biomedical Engineering, and also the department's Event Association convener, feel privileged to give the valedictory address for the Faculty Development Program on funded project application. Respected speakers, faculty members, student volunteers, and dear participants, once again, a very good evening to all of you. It gives me great pleasure to address you all for the successful completion of this 5 days virtual faculty development program on funded project applications organized by the Department of EEE and BME in association with Academic Staff College. I would like to express my heartfelt gratitude to all our extinguished speakers, Dr. J. Jayaprakash, Dr. S. Sendil Kumar, Dr. V. Natarajan, Dr. G. Jayanti, Dr. K. Gomati, and Dr. P. Gomati Nakajoti, and Dr. Tirumavakarasu sir, who have shared their vast knowledge and experience with us on various topics related to funded project application. Your insights have been invaluable and will be cherished by all the participants. I would also like to extend my sincere thanks to the faculty members who have put in a lot of effort to make this event a grand success. Special thanks to the student volunteers Geeta, Hemalata, Kirtana, Mohana Sandhya, Monish, Rajeshwari, Dinesh from 3rd BME, and Janani, Rizwana, Sneha, Vasundhara from 2nd BME, and Geetesh from 2nd Triply for their exceptional contribution in delivering the welcome address, vote of thanks, and comparison. I would like to express my gratitude to Dinesh Kumar of 3rd BME for his contributions in making the FTP browser and Mohammed Azimuddin of 3rd Tripoli for his excellent work in certificate design. I would like to thank Nicholas Pondraj of 3rd BME for recording the session and permitting everyone to the session. Furthermore, I would like to extend my appreciation to Kirtana Priyadarshini of 3rd BME for her commendable work in creating the Gmeet link, Google form for registration and attendance, report writing, certificate writing, and for coordinating with me and also with all the student coordinators for this event. I'm very happy to say that Kirtana Priyadarshini is a good organizer and a great leader. I want all students involved in any department activities to be like her and follow her steps. I would like to thank the department faculty members Dr. R. Shivanand, Dr. S. Krishnaveni, Engineer A. Raja, and Engineer B. R. Shankari for delivering guest introduction and making the faculty development program a success. Last but not least, I would like to thank our HOD, Dr. K. Saravanan, who had been the backbone for any department event and also for his constant support and encouragement for conducting this FTP. Thank you one and all for the contribution and dedication towards this FTP. Once again, thank you participants for being a part of this FTP. We hope that you have gained valuable insight that will be beneficial to your future endeavors. Thank you all and have a great day ahead.
Now it's time to deliver vote of thanks.
Good afternoon, everyone. It gives me immense pleasure to deliver the order of thanks on the successful completion of the final day of Faculty Development Program on funded project application. And foremost, I would like to express my gratitude to Dr. K. Saravanan, the head of EEE department, for his valuable guidance and support in organizing this event. I would like to thank Dr. F. Fariza, the coordinator of this program, for her tireless effort in ensuring that everything ran smoothly. A special thanks to our esteemed speaker, Dr. P. Tirunavakarasu and Dr. P. Gomati Nagajoti, who enlightened us with their expertise and knowledge in the field. I would like to thank all the participants who attended the program and made it a success. Your active participation and enthusiasm has made this event a grand success. A big shout out to all the volunteers who worked behind the scenes to make the program a success. Your selfless service is deeply appreciated. And finally, I would like to conclude it with a quote that truly expresses our feelings of gratitude towards all of you. Gratitude unlocks the fullness to life. It turns what we have into enough and more. It turns denial into expectance, chaos into order, confusion into clarity. It can turn a meal into a feast, a house into a home, a stranger into a friend. Once again, I thank you all for your participation and support. Thank you.
Kindly fill the attendance which was posted in chat. Once
Participants,
again,
for your kind information, those who have attended 3 sessions and submitted the attendance and feedback form will be receiving your participation certificate through your registered email ID. Uh, Maybe it may take maximum by tonight or by tomorrow. Thank you.
Once again, I would like to thank everyone for their active participation in this FDP. We hope that the knowledge gained from this FDP will be beneficial to all the participants in their future endeavors. Thank you and have a great day.